Hi, I'm Louise, and in this video I'll explain some of the issues that your business might encounter if you want to connect renewables, such as solar panels, to the electricity grid. Most businesses take their electrical grid connection for granted. Sometimes companies might need to apply for a bigger connection, especially if they are installing lots of new equipment, and this is a fairly straightforward process. But when it comes to installing renewables on your premises, things can get a little more complicated. Let's start off by taking a look at the grid. In the UK, power has traditionally been generated centrally at a small number of very large power stations. Power is then transmitted across the country at very high voltages, using overhead cables or sometimes buried cables. This is called the transmission network. In our towns and cities, there are electricity substations, which are called primary substations. These distribute the power at high voltage to secondary substations, which then transform the voltage down even further to our homes, businesses and factories. Some of these cables are overhead with pylons or wooden poles holding them up, and some are buried. Finally, there are the cables that connect to our homes and businesses at more familiar lower voltage levels. All of this infrastructure makes up the distribution network. The distribution network is managed by the Distribution Network Operators, or DNOs. In the UK, there are 14 DNOs, and they all follow a common framework of rules for how they operate their systems. As I previously mentioned, the whole system was designed to transmit power between large centralised power stations and end users in one direction only. Now that we have a lot of decentralised energy sources, such as solar PV on buildings, power can flow in directions that the system wasn't originally designed to be for, and this can cause problems for the DNO. Consequently, there are rules and processes that have to be followed if you want to install something that can generate power on your building. Before we carry on, let's introduce some of the technical jargon used when talking about grid connections. The first of these is the fault level. Power network engineers use this term to describe the strength of a section of the network. Imagine an excavator goes through a buried cable in the street and causes a short circuit. The amount of current that could flow during this fault condition is called the fault level. If you add some extra generation capacity to the network, the fault level is going to increase. So the DNO has to ensure that their protection equipment can handle the extra power. Rural areas tend to have low fault levels because the electrical infrastructure was not designed to carry large loads, and physically it's smaller. Adding just a small amount of local generation can increase the fault level beyond safe limits, so it can sometimes be necessary for parts of the network to be upgraded before your renewable energy project can go ahead. Voltage rise. When you connect a new piece of equipment that can generate power to the network, it can cause the local voltage level to rise. If this starts to go outside statutory limits, equipment in the substation will automatically cut off the power, causing a local blackout. Voltage control. Power engineers often talk about taps, and sometimes they give the reason for your renewable energy project not going ahead as out of taps. They are talking about connections on the transformers which step the voltage down between the transmission network and the distribution network. Engineers can physically adjust the voltage level if it's too high or low by moving connections between different tapping or taps on the transformer secondary. Some primary substations have automatic tap changers installed, which perform this function autonomously. Reverse power flow. Because the system was originally designed for power flow in one direction, substations equipment such as online tap changers can malfunction if power starts to flow in the opposite direction. This can lead to problems like voltage rise and blackouts. Power quality. Poor quality inverters can cause issues such as harmonics, high neutral currents, or other problems on the local network, so the DNOs need to ensure that anything connected meets certain standards. As you can see, there are numerous technical issues faced by the DNOs. If you're planning just a small renewable energy installation, your installer can go ahead and get the system up and running without needing to get their approval. But the equipment has to be type approved, and the installer has to notify the DNO within 30 days of installation. A small installation is one which can generate no more than 16 amps per phase. So if you've got a 3-phase power supply and you want solar panels on your building, you'll be limited to around 11 kilowatts of generation, or to put that in other terms, about 36 solar panels. For bigger systems, you have to get permission in advance from the DNO. In some cases, it could be necessary for the DNO to upgrade part of their network, which could significantly increase the cost of the project. In the power industry, this application process is known as G99, which is the name of the technical standards that have to be followed. When planning any significant renewable energy installation, it can be useful to check out the state of the network in your area. DNOs have interactive tools and heat maps on their websites. Let's take a look at an example. If you navigate to your DNO's heat maps or other online tools, you'll be able to see which primary substation feeds your building. Here we can see the technical details of the primary substation. In this example, we can see that the fault level is expressed as a percentage rather than an actual power level. A percentage of 71% allows us to see that there is potentially some capacity for adding renewable generation via this substation. If this percentage were near 100%, then this would be a constraint that could make the project unviable or require costly upgrades to the network. Let's move on to look at reverse power flow capability. The information shows that the substation can handle 25 MVA of reverse power flow. Unless you're planning a really big installation, this will probably not be a constraint. Unfortunately, the voltage control for the substation has been classified as out of taps, so the substation transformer is being operated close to the statutory voltage limit, and it is unlikely that any additional renewable energy generation could be accommodated because of this. Sometimes the DNO mark their substations as red, amber or green to give you a quick indication of the availability for connecting additional generation. It's a good idea for your installer to check the heat maps and speak to the DNO before committing too much time and resource to planning your project. Grid specialist consultants can also help here. So far, I've discussed renewable energy generation systems, like solar panels, but you might be thinking about installing battery energy storage systems alongside your generation system. Because battery energy storage systems can supply power to the grid, adding battery systems can require permission from the DNO as well. Finally, you might also be thinking about putting in some kind of electric vehicle charging infrastructure, either for your staff to use or to charge your own vehicle fleet. EV chargers require a lot of power, so it might be necessary to have your supply upgraded. The next generation of electric vehicles will also have the capability to supply power to the grid, so they can be thought of in the same way as batteries. A project like this would also likely require an application to the DNO before it can proceed. I hope you found this video useful. You can find out more information about grid connections by downloading our fact sheet, or if you're interested in other energy efficiency technologies, we have more videos available. Thank you for watching.